Lecture 26, Strain from Deformed Markers and the Mohr Circle. In the previous lecture, we looked at several geometrical techniques to determine the strain from deformed markers in the rock. In this lecture, we will also consider deformed markers, but use the Mohr circle to determine the strain ellipse from them. This lecture covers 3 examples from Chapter 12 of Reagan. Markers from which angular changes can be determined are relatively common. The angular shear can be determined directly from a deformed symmetrical fossil. The first example involves one angular shear associated with a line in known angular relation to the principal axis of the strain ellipse. A deformed trilobite is exposed on the plane of slaty cleavage and its median line, M, makes an angle of 39 degrees with a lineation marking the S1 direction. The angular shear associated with this line is plus 30 degrees. Determine the shape of the strain ellipse. We first draw a rosette by assembling the median line M, and the line representing the S1 direction, both radiating from the same point. The angle between these lines is 39 degrees. We then draw the Mohr circle for strain diagram. The horizontal axis is lambda prime, and the vertical axis is gamma prime. On this diagram, we draw a line from the origin with a slope angle equal to the angular shear of the line M, in this case plus 30 degrees. Notice that this line should plot below the horizontal axis since positive angular shear and shear strain values plot there. Then, at a convenient but arbitrary distance along the sloping line psi M, we locate the pole OL, which is then a first point on the Mohr circle. Then at OL, we place the rosette with the arm M along the psi M line. The arm representing S1 intersects the horizontal axis at lambda prime 1, which is a second point on the Mohr circle. We can then trace the perpendicular bisector of the segment OL lambda prime 1. This bisector locates the center C of the Mohr circle on the horizontal axis. Then, we can trace the circle with radius C, lambda prime 1. Because the pole OL is arbitrarily located, the two principal values, lambda prime 1 and lambda prime 3, cannot be uniquely determined. However, they are proportional to an unknown scale ratio K. The strain ratio Rs is the ratio between S1 and S3. It can be determined from this equation. It is 1.785. Though we don't know, let's assume the deformation is plane strain and constant area. Then, S3 is equal to 1 over S1, and S1 is equal to the square root of Rs, or 1.34, and S3 is equal to 1 over the square root of Rs, or 0.75. This is the end of the exercise. Let's look at a similar exercise, but in this case we know the shear strain of two lines, and the angle between the lines. The angle between the hinge lines of two deformed brachiopods is 30 degrees. The angles of shear associated with these lines are minus 35 and plus 25 degrees. Determine the ratio of the principal stretches and their orientation. We start by constructing a rosette from the hinge lines A and B. The angle between these lines is 30 degrees. Then, on a pair of lambda prime gamma prime axes, we can draw the hinge lines making angles of psi A and psi B with the horizontal lambda prime axis, and passing through the origin. Notice that positive angular shear plots below the lambda prime axis. Line B which has positive angular shear plots below the lambda prime axis, and line A which has negative angular shear plots above that axis. Then, we arbitrarily locate the pole OL on either of the lines, line A, or line B. Here we choose line A. We position the rosette at OL, with arm A, along the psi A line. Arm B then intersects the psi B line at P'B. The perpendicular bisector of the chord OL P'B locates the center of the Mohr circle, C, on the lambda prime axis. We complete the circle with radius C OL. On the Mohr circle, the lines OL lambda prime 1 and OL lambda prime 3 tell us the orientations of the principal directions relative to arms A and B. S1 makes an angle of 10 degrees with respect to arm B, and S3 is of course perpendicular to S1. From the distances to the two intercepts, we can determine the strain ratio, Rs, which is 1.98. The strain ellipse in the Mohr circle and on the rock slab then looks like this. This is the end of the exercise. The final example deals with finding the strain ellipse from 3 measured stretches, along different directions. Boudins, stretched elongated crystals, and belemnites are excellent markers from which the stretch can be measured. From the 3 stretched belemnites in the figure, determine the principal stretches and their orientations. We start by measuring the original and final length of the belemnites, and from them we can calculate the stretch of these markers, SA, SB, and SC. From these stretches, we can calculate the lambda prime of the belemnites, lambda prime A, lambda prime B, and lambda prime C. We then make a rosette, with the belemnite of intermediate lambda prime, in this case belemnite C, in the middle of the rosette. We draw the vertical gamma prime axis, but not the horizontal lambda prime axis. Then, using a convenient scale, we add 3 parallel lines at distances equal to the values of lambda prime A, lambda prime B, and lambda prime C. We arbitrarily locate the pole OL on the intermediate lambda prime C line, and place the rosette at OL so that arm C lies along this same line. Points OL, P', and P', lie on the circle. We draw perpendicular bisectors to the chords OL P', and OL P'. These bisectors will intersect at the center, C, of the Mohr circle. Through the center, C, we draw the horizontal axis lambda prime, and also draw the circle with radius C, OL. We can measure lambda prime 1 which is 0.2, and lambda prime 3 which is 0.6. The corresponding stretches are S1 equal to 2.24, and S3 equal to 1.29. From OL, we can draw lines to lambda prime 1 and lambda prime 3. These lines give the orientation of the principal axes S1 and S3, relative to the rosette. This is the strain ellipse on the Mohr circle and the rock slab. This is the end of the exercise. To learn more about this, read these sections from Reagan and answer these questions.